In this video, we'll explore the mathematical language routine, compare and connect.
Before diving into the routine, we want to first outline what you can expect from us during our time together. We'll introduce compare and connect, and then model the routine. We'll offer a guide to the routine and connect you to resources for future inquiry and practice.
In order to make this the best experience for you, while viewing this video, we suggest you do the following. Pause at critical reflection points to give yourself time to think. Pair this learning with the guide and note catcher, the provided resources that go along with this information. Additionally, we encourage you to experience this video with a coach, colleague, and/or PLC. Collaborating with others can help to identify ways to make this routine easier to implement and increase student buy-in. And finally, learning is a journey. Come back to this video as many times as you need to grow. Equitable algebra instruction requires us to engage all students' thinking through positioning them as sense makers and valued contributors in mathematics learning. One approach to strengthen opportunities and build structures for students to communicate their ideas to others is a multi-step academic routine called Compare and Connect. So, what does this routine entail? Think of Compare and Connect as having three criteria: mathematical language, representations, and cognition. When you apply all steps of the routine, you engage students in all three criteria. Specifically, 1. The teacher leads students to progress to the mathematical learning goal through the use of mathematical language. 2. The teacher leads students to comprehend multiple solution methods by identifying, comparing, and contrasting different mathematical representations. And 3. The teacher leads students to cognitive engagement by optimizing output and cultivating conversation. Throughout the video, we'll return to these criteria to help us customize this routine for our students. Let's see Compare and Connect in action. Imagine you're a student in an Algebra 1 lesson and about to experience Compare and Connect. To engage as a student during the model, please access the note catcher to record your ideas.
Now that you have your note catcher to record your responses as a student, let's start the model. I will play the role of the teacher applying the routine.
And I will narrate the steps of the routine as he models. The teacher will model 2 steps. First, starting with stating the purpose or the rationale for the mathematical language routine. Then, the teacher will present the task in question that students create a display of their thinking to solve. To make the most of this model, access the video's note catcher now and write your thoughts as if you were a student. Here's the teacher applying the routine.
Okay, everyone. We recently interpreted functions in concrete real-world terms by examining the successive heights that a tennis ball reaches after several bounces on a hard surface. Today, we continue analyzing measurements of the maximum height of a tennis ball after bouncing several times on a surface through a mathematical language routine called Compare and Connect. The purpose of this routine is to prepare us to discuss the question, which is more appropriate for modeling, a linear function or an exponential function? Working with your group, create a display showing your mathematical reasoning for choosing whether the data can appropriately be modeled using a linear function or an exponential function. Your display can be a concrete representation, such as an illustration of the information you see in the table. Your display can be a visual representation, such as a graph. Or your display can be an abstract representation using numbers and symbols. Please get started.
You've just seen a teacher model the directions for Step 1, preparing students to compare and connect, and Step 2, the students displaying their thinking. Now, pause the video and identify which is more appropriate for modeling the data, a linear function or an exponential function on your personal note catcher. After After students create their displays, the teacher has students find similarities and differences between them. Watch how this is modeled. Here's the teacher applying the compare displays step of the routine.
Recall that we worked to determine if a linear or exponential function is more appropriate for modeling the measurement of the maximum height of a bouncing tennis ball. Now, let's compare two approaches to see how they are alike and different. Compare both representations. How are they similar?
Here, pause the video and identify on your personal note catcher how both representations are similar. When finished, continue watching to see what happens next.
Our group noticed that both representations show the height from which the ball is dropped, and both representations show the bounce height decreasing exponentially. Okay, great. Now compare both representations again. This time, how are they different?
Again, pause the video. Using your personal note catcher, document how the representations are different. When finished, continue watching for next steps.
Our group noticed that the graph shows that after 4 bounces, the ball is almost done bouncing, and the equation shows the rate at which the height decreases after each bounce. This seems to be exponential decay.
In the final step, the teacher listens for and harnesses observations that highlight the assumptions and choices that led to different representations. After students discuss their representations, the teacher further supports students by having them reflect on the assumptions they made when creating their displays. Let's see him do this.
Now that we've described the similarities and differences between two representations, we determined information in the table represents an exponential function rather than linear. Take a moment to reflect. How has your thinking about functions changed after comparing displays? Please respond using the following sentence frame. Before I assumed blank, now I realize blank.
Before you watch the teacher implement this portion of the routine, pause the video. On your note catcher, internalize potential ways one's thinking about functions can change after comparing their peers' displays. When you're done, continue watching.
Possible student responses could be, before, I assumed graphs show the difference between a linear and exponential function best. Now, I realize a function can do so just as well. Before, I assumed abstract functions are enough to get the task correct. Now, I realize that a visual representation makes the ball bouncing more understandable.
You experienced one way to apply, compare, and connect. This language routine provides students opportunities to integrate different representations of mathematical concepts without prescribing how they should do so, giving them the agency to connect their own experiences with mathematical concepts and communicate them to others. Check your understanding of the routine with a few questions. Summarize the routine as a series of 4 steps. Pause the video to give yourself time to think. Access your note catcher to check your thinking, and unpause it when you are ready to check your understanding. Be the teacher who applies this routine using the following steps. First, state the purpose so students are able to internalize the rationale for the routine. Next, students create displays to represent their thinking. They can choose to show their thinking concretely, visually, abstractly, or even any combination of the 3. Afterward, students compare responses. They focus on similarities and differences among the displays. Finally, students explain how representations show mathematical concepts, making connections. Here's something else to consider. During the routine, what are the teacher and students thinking about? Pause the video to give yourself time to think. Access the note catcher to record your thinking, and unpause it when you're ready to check your understanding. You probably noted that the teacher continually uses students' displays to explore conceptual connections, and the students continually assess and revise their ideas through communication and collaboration. Optimizing output and cultivating conversation are layered principles within the Compare and Connect routine. Take a moment now to reference your Compare and Connect guide as we explain these two principles. We facilitate opportunities for students to optimize output. That's the understanding of how variations in assumptions and choices may lead to different predictions and solution strategies. This looks like students using and refining their mathematical language during conversation to be better understood and to access the mathematical thinking of their peers. Simultaneously, we cultivate conversation, creating opportunities for students to view peers' mathematical thinking and discuss how problems are solved to better make sense of the mathematical concepts and context. Grade instruction starts at the planning level. And while we'll look at all three criteria in this process, we'll zoom into the process of planning for mathematical language. Access the Note Catcher and Guide now to reference the full task once again.
The Compare and Connect routine rewards students for communicating ideas. Some curricula have built-in guidance for this routine, like the Rice curriculum. But if you're wondering how you can bring this into your classroom now, let's see what makes an activity a good fit for this routine. So, how do you plan a grade-level task worthy of optimizing output and cultivating conversation? Let's go back to the model. Here's the Algebra 1 task from before, choosing an appropriate model. I selected it because I believe it both optimizes output and cultivates conversation. This gives students the opportunity to concentrate on displaying and communicating their thinking rather than just solving the problem. Why, you ask? When planning the Compare and Connect routine, I had the following question top of mind. What mathematical connections do I want the students to make between representations? Immediately, I noticed the task can be represented concretely, visually, or abstractly, even though it doesn't require students to do so. With the task identified, I'll plan to provide access to the rationale. This rationale or purpose provides the answer to the question of why the Compare and Contrast routine is being used. Since the goal of the task is to differentiate linear and nonlinear functions using the context of a bouncing ball and tabular data, students must expect that we must communicate our ideas to make this distinction as a class. With the purpose exposed, I will plan what information students will use to create their displays. Because the task eventually asks students to create an equation, an abstract representation, this must be scaffolded for students to understand how previous learning about the concrete and visual representations connect. Question 1 is where I will provide the option to represent their thinking concretely, visually, or abstractly, whichever they prefer. Once they've displayed their thinking, I'll plan to ask, how are representations similar and how are they different? These questions are intentionally open-ended so students can generate and use mathematical language in ways that make sense to them. After students make low-inference observations about how they compare and how they differ, we will dig deeper into how the concepts of linear and exponential relationships are connected. Since I anticipate students will notice how the ball bounce height decreases at an exponential rate, we can focus more on how the graph in representation 1 connects to the structure of the equation. As they look at the structure, I anticipate they will also comment on how useful both representations are in order to model the context. Discussing the utility of both representations helps students not only reflect on the concept of exponential growth, but also generate ideas of how to present thinking and for which purposes.
Check your understanding again. Is the goal of Compare and Connect to solve a mathematical task? Pause the video to give this some thought. Access the Note Catcher to record your thinking, and unpause it when you are ready to check your understanding. No, Compare and Connect is not used to solve tasks or merely for answer getting. Rather, it allows students to process concepts through collective thinking and to develop multiple ways to communicate mathematical language.
We encourage you to use what we've modeled to now plan and apply a task that you will teach. The RAISE curriculum is full of rich tasks that optimize output and cultivate conversation through compare and connect. Access the RAISE curriculum now to first identify a task for this routine that you will teach. Select an appropriate task and ask yourself, does the task provide an opportunity to represent thinking concretely, visually, and abstractly? Pause the video now to identify your task and return to advance when ready.
Now that you have a task, access the Compare and Connect guide to inform your planning. Access the RAISE guide now, and specifically the plan column's mathematical language, representations, and cognition criteria. Using the guide, first, plan to state the purpose of using the Compare and Connect routine. Next, give time for students to work together to display their thinking through concrete, visual, and abstract representations. Then, provide time for students to discuss multiple representations by asking how they are alike and different. Finally, lead students to make connections between representations and reflect on their experience. Pause the video now to plan your application and return to advance when ready. What could it take to improve this routine even further? Let's zoom in on one of the ways we can optimize the representations created in this routine. Access the note catcher and guide now to reference the full task once again. Optimizing this routine means comparing and connecting all three concrete, visual, and abstract representations, or connecting the discussion to students' lived experiences. Let's see the first option.
Recall earlier when we compared a visual representation, the graph of the tabular data, and an abstract representation, the equation with just numbers and symbols. To optimize this routine, we can show three representations by showing student work that shows what's actually happening, a tennis ball bouncing. Now, we can have students reason across the entire concrete, visual, and abstract progression, representing the concept of a function in three different and connected ways. To help cultivate conversation, I'll ask, what is similar across all three representations? In what ways do the representations differ? To provide opportunities for all students to discuss their thinking orally, visually, and through writing, I'd ask them to discuss with their group. Which representation do you prefer to model functions and why? They can choose to communicate their thinking in any way they prefer, including using a real tennis ball to support their reasoning.
We set the purpose to make algebra accessible to all students. We also looked at and engaged in the criteria for effective implementation of Compare and Connect. Now it's time for you to determine your next steps.
Where will you focus your energy to effectively implement Compare and Connect for your students? First, reference the RAISE guide before we ask you to consider these questions.
If you are new to this routine or just beginning to identify tasks in which to cultivate conversations between your students and optimize their output, then begin here to identify paths and plans for those opportunities.
Once you have identified a task and described how it will optimize output and cultivate conversation, begin here to define the major steps of using Compare and Connect in your classroom.
When you are ready to apply the routine in your lesson, you are here.
When you seek to optimize the routine to further support language use and multiple representations, you are here.
When you have reached the place where Compare and Connect is a normalized routine and you would like to extend the effectiveness to other dimensions of the mathematics classroom, you are here.
Review the resources listed at the end of this video.
We enjoyed sharing this routine with you, and we're hoping you apply Compare and Connect to provide access to algebra for all students.